Greetings, everybody. Welcome back to Weekly Wildlife Wisdom here on the channel Factutainment. And as always, I've been your host, Zero Yeti. Happy Fossil Day, and today we're going to be doing something a little unique. We're going to be going through, seven unique fossils from our world's history, but we're also going to be covering a fossil of each main type of fossil. So there are around 5 main types of fossils. There is permineralization, where the body of an animal, the bones, and sometimes other organs get mineralized and turned into like a different mineral than they originally were. Then there is carbon film fossils. These are usually like of invertebrates or soft organisms, where the animal becomes carbonized. And you see like an imprint in coal or soft rocks, shale, slate, etc. Then you have direct preservation remains, which is when an animal gets preserved in like tar or ice or amber. And then you have molds and casts, where an animal, usually an animal with like a hard shell, they die. They form a mold or a cast in the sediment where they die. Their initial remains rot away, and then either the impressions are left and fossilized, or new sediment and new material comes in and fills those molds and makes a cast of the animal. And lastly, there are trace fossils. These are stuff like animal burrows, sometimes like egg remains, dinosaur like animal trackways are another common one. So it's not the direct fossils of the animals, but like impressions that they left behind that they were here. So first animal on the list is Umoonasaurus, which is an extinct genus of pliosaur belonging to the family Leptocelidae, which lived throughout the shallow seas covering parts of what is now Australia and New Zealand during the Aptian and Albian stages of the late Cretaceous period, around 120 to 110 million years ago. The holotype is an opalized skeleton nicknamed Eric. Eric was discovered by an opal miner digging through the Zorba Extension opal field in the town of Cooperpedy in 1987. So Eric is an example of permineralization, where his bones have become opalized and turned into opal as different elements have replaced the calcium and other trace elements in the bones themselves. So he consists of a near completely intact skeleton, and it's the most complete opalized vertebrate known, and became part of the fossil collection of the Australian Museum in 1993 after money to purchase the specimen was raised by the schoolchildren of Australia. Since 1987, 4 more specimens, 2 of which are also opalized, have been recovered from the Bulldog Shale in southern Australia. After years of study on each of these specimens, doctors Keir, Schroeder, and Lee have confidently declared them as belonging to a new species, Umoonasaurus demosclilis, in 2006. The generic name is a combination of the Akeiron name for the Cooperpedy region, Umuna, and the Greek word sauros, meaning lizard. The specific name comes from the Greek words demos and sklia, meaning of the people and sea monster, respectively, referring to the public donations used to acquire the holotype specimen. Reaching 6.5 to 8.5 feet in length, Umoonasaurus was a fairly small 4-flippered marine reptile. It had a small triangular skull with 3 distinctive crests. There was a tall, narrow crest running along the middle of the front of the skull, and 2 shorter yet broader ridges at the back of the skull, with one being over each eye. In life, Umoonasaurus would have inhabited the polar inland Urmanga Sea. These waters, while frigid, sport a wealth of life, including mollusks, bony fish, crustaceans, chimeras, rays, and other marine reptiles such as the elasmosaurid Opalionectes, the ichthyosaur Platypterygius, and the giant pliosaur Chronosaurus. Next up, we have Arctodus, which is a distinct genus of short-faced bear that inhabited Beringia and North America during the Pleistocene period, some 2.5 million years ago to 12,000 years ago. The first remains of Arctodus, consisting of a mostly complete skeleton, were named and described by Joseph Leidy in 1854. Today, 2 species are recognized: the lesser short-faced bear, Arctodus pristinus, and the giant short-faced bear Arctodus simus, with both species being relatively rare in the fossil record. A. pristinus was largely restricted to the early Pleistocene of the eastern United States, whereas I. simus lived during the late Pleistocene throughout most of the United States and Mexico, Beringia, Alaska, and Canada. Now, Beringia is the Bering land bridge that existed during the Ice Age, and it connected Asia to North America. It's now covered by the Bering Sea. So A. simus has also been much more well studied, thanks to a wealth of individuals having been incredibly well preserved in the tar pits at La Brea, which is an example of direct preservation. Both species represent some of the largest terrestrial mammalian carnivorans to have ever existed, with A. pristinus averaging around 4 to 6.5 feet in length, 2 to 3 feet tall at the shoulder, and 250 pounds to 500 pounds for females, 5 to 7.5 feet long, 3 to 4 feet tall at the shoulder, and 600 to 1,000 pounds for males, while A. simus averaged around 7.5 to 10.5 feet in length, 3 to 4.5 feet tall at the shoulder, and 600 to 1,200 pounds for females, and the males averaged around 9 to 12 feet in length, 4 to 5.5 feet tall at the shoulder, and 1,000 to 2,000 pounds in weight. Both species have disproportionately short snouts compared to most other modern bears, giving them the distinctive name of short-faced, which is a trait they share with their cousin, their closest living relative, the spectacled bear. This apparent shortness is an illusion caused by the deep snouts and short nasal bones, giving Arctodus a deeper but not shorter face than most living bears, allowing the animals to have a better sense of smell and stronger bite force. Arctodus also sported higher shoulders, a short sloped body, long muscular legs, which allowed them to run and travel both at higher speeds and for greater distances than most modern bears. In life, Arctodus would have inhabited the open woodlands, grasslands, wetlands, montane forests, and the mammoth steppe of North America, acting as a colossal opportunistic omnivore and a super scavenger of sorts, feeding upon leaves, stems, fruits, nuts, barks, grasses, flowers, as well as deer, camelids, tapirs, bison, and young mammoths, young mastodons, and young ground sloths. Next up is one of my personal favorites, and it's a fossil I actually have in my collection. Hallucinogenia, which is a genus of bizarre worm-like animals that lived throughout the middle of the Cambrian period, roughly 521 to 497 million years ago. It is known from articulated carbonized fossils from Burgess Shale-type deposits in Canada and China, and from isolated spines from around the world. This is an example of carbonization for fossils. Hallucinogenia was originally described by Charles Walcott as a species of polychaete worm Canidia in 1911. In 1977, Simon Conway Morris recognized the animal as something quite distinct, establishing a new genus, but with no known specimens at the time that showed both rows of legs. Conway Morris reconstructed the animal as walking on its spines, with a single row of legs interpreted as tentacles coming on the animal's back. A dark stain at one end of the animal was interpreted as a featureless head, and the other scientists at the time were offered the alternative interpretation of considering hallucinogenia to be an appendage of a larger unknown animal. In 1991, Lars Ramskjöld and Hyo Zhang, working with additional specimens of a hallucinogeniid from the lower Cambrian Mao Tianshan shales of China, reinterpreted hallucinogenia as a Lobopodian, a legged worm-like taxon related to velvet worms and tardigrades. They inverted it, interpreting tentacles which they believed to be paired as walking structures and the spines as protective. The blob-like head is actually a stain that appears in many specimens and is now a preserved portion of the anatomy. Later research in the mid-2010s clarified the longer end is a head with an antroventral mouth and at least a pair of simple eyes, proving Ramskjöld and Zaiken's interpretation of the animals to be correct. In life, the about a 1/4 inch to 2.5 inch long hallucinogenia would have dwelled along the primitive reefs and algal fields of the shallow Cambrian seas, where it fed upon plankton, algae, and detritus, alongside many other bizarre creatures, such as Anomalocaris, Opabinia, Wawaxia, Hyrotrioskjan, and, of course, trilobites. Next up, we have Isotellis, which is a genus of asaphid trilobites, which live throughout the shallow seas that covered what is now the United States and Canada during the Ordovician period, some 470 to 444 million years ago. Trilobites are an extinct group of arthropods related to the horseshoe crabs, insects, arachnids, and crustaceans. The name trilobite means three-lobed animal, from the three longwise divisions or lobes of the body. First name described by Dr. Decay in 1824, the genus name Isotellis is derived from the Greek isos, meaning equal, and telos, meaning end, and refers to the fact the tail shield is approximately equal size to the head shield. Since then, 16 species have been named and described, with one of the more common species, Isotelus maximus, having been found in particular abundance within the state of Ohio, where it has the honor of being the official state fossil. While most species of Isotelus tend to reach around 10 to 20 inches in length, one species, Isotelus rex, grew to be upwards of 28 inches long and 16 inches wide, making it the largest trilobite known to have ever lived. Most fossils of Isotelus consist of mineral calcite casts of the dorsal top shell and exoskeleton, with the organs, antennae, and many pairs of legs typically not being preserved. However, rare impressions of the legs are known, and in life, Isotelus would have traveled along the ocean floor, burrowing and sifting through the sediment as it hunted worms and other bottom-dwelling invertebrates, while trying to avoid being preyed upon by even larger invertebrates, such as the large orthoconic straight-shelled cephalopods and the giant eurypterids. Next up is an example of a trace fossil, and later regular fossil, Paleocaster, which is an extinct genus of prehistoric beaver that lived throughout what is now the Great Plains of Central North America during the late Oligocene period to early Miocene period, some 33 to 20 million years ago. The discovery of Paleocaster sprang from the discovery of the Devil's Corkscrews in the plains of Sioux City, Nebraska, which are tree-sized, screw-like underground formations. These puzzling, elongated spirals of hardened earth can reach up to 10 feet in depth. And they first came to notice to Dr. E.H. Barbour of the University of Nebraska in 1891. He initially described them as giant freshwater sponges that must have existed in big, massive freshwater lakes. Then it was argued by many that the corkscrews were the roots of a curious type of extinct plant. Later, Dr. Barbour proposed the devil's corkscrews were the burrows of large rodents and Latinized the name to the ichnofossil name Daimon helix and Daimon nilix and Daimon elix, and classified them by shape and size. One Dr. Theodore Fuchs suggested that they were the work of a Miocene gopher. Arguments about the true origins of the devil's corkscrews continued well into the 20th century, only finally ceasing when a fossilized beaver was discovered in one of them. Today, 4 species of Paleocaster are recognized: P. focer, P. magnus, P. wallereti, and P. peninsulatus. Reach around 1 to 2 feet in length and 3 to 8 pounds in weight. Paleocaster look like a cross between a modern North American beaver and a gopher, sporting small ears and eyes, relatively long tails, and unlike most burrowing animals, they had super long, quickly growing front teeth, which they used to excavate their burrows rather than their claws. Paleocaster was a highly sociable herbivore, which lived in large colonies and fulfilled a similar ecological niche to modern prairie dogs. Recent research as to why Paleocaster would have made helical burrows suggests that it was a combination of a way to maintain more consistent temperatures and humidity levels. It was better at keeping out predators and was easier for the animals to transport food and materials in and out of their burrows than a straight burrow would be. Next up, we have Celophysis, which is an extinct genus of Celophysis theropod dinosaur, which lived throughout what is now North America during the late Triassic period, approximately 228 million years ago to 201 million years ago. The first remains, consisting of a couple partial skeletons, were unearthed in 1881 by David Baldwin in the Chinle Formation of northwestern New Mexico. Baldwin presented his finds to his boss Edward Drinker Cope, who in early 1887 referred to the specimens collected as two new species, C. bari and C. longicollis of the genus Celoris. Later in 1887, Cope reassigned the material to yet another genus, Tanystropheus. 2 years later, Cope corrected his classification after realizing differences in the vertebrae and named them Celophysis with C. bari as the type species. The name Celophysis is Greek for hollow form in reference to the animal's hollow vertebrae. However, the first finds were too poorly preserved to give a complete picture of the animal. In 1947, a substantial graveyard of over 1,000 Celophysis skeletons, which had all perished in a flash flood, had then been preserved by the sediments brought by that said flash flood. They were found by George Whittaker at the Ghost Ranch in New Mexico, who presented the find to the American Museum of Natural History, which prompted paleontologist Edwin H. Colbert to conduct a comprehensive study of every Celophysis fossil up to that date. The Ghost Ranch specimens were so numerous, including so many well-preserved and fully articulated specimens, that one of them has since become the diagnostic or type specimen for the entire genus, replacing the original poorly preserved specimens. In addition to this, there are several other Celophysis specimens found from throughout North America, including many trace fossils, including dinosaur trackways, which I think is just pretty neat. Reaching 6.5 to 9.5 feet in length, 2.5 to 3.5 feet tall, and 33 to 55 pounds in weight, Celophysis is frequently used as the archetypical example of an early carnivorous dinosaur from the Triassic. Its hollow bones, bipedal stance, two legs that supported the body from underneath as opposed to sticking out to the sides, and smaller front arms than its back legs, and it had a head mounted on an S-curved neck, all served to give it the distinctive small theropod look. And then lastly, we can't do a fossil day without talking about mummies, so we're going to go with possibly the most famous dinosaur mummy, which is Edmontosaurus, an extinct genus of large hadrosaurid dinosaurs lived throughout North America, from Colorado to Alaska during the late Cretaceous period, some 75 to 66 million years ago. Edmontosaurus has had a long and complicated history in paleontology, having spent several decades in various species classified into other genera. The first fossils, named Edmontosaurus, consisting of two partial skeletons, were discovered in the Horseshoe Canyon Formation of the southern Alberta, Canada, by Lawrence Lambe, who described naming the animals as Edmontosaurus regalis, meaning king-size Edmonton lizard, in 1917. However, several other species are now classified as Edmontosaurus that were named earlier. Best known of these is Edmontosaurus annectens from Wyoming, named by Orthniel Charles Marsh in 1892, originally as a species of Cliosaurus, and known for many years as a species of Trachodon, and later as Anatosaurus annectens. Two additional important specimens consisting of mummified remains that preserve not only the bones and skin, but the muscles and some internal organs, were recovered in 1908 and 1910 by Charles Haslius Sternberg and his sons from Wyoming's Lance Formation. These remains were initially classified as Trachodon annectens, and since then many more specimens of Edmontosaurus have been found, including another mummy nicknamed Dakota from the Hell Creek Formation of North Dakota. And over time, Anatosaurus, Anatotitan, Trachodon, and Arugacnolic have all become synonyms of Edmontosaurus, considerably extending the genus's range both geographically and temporally. Two species are considered valid, E. regalis and E. annectens. Reaching 30 to 43 feet in length and around 4 to 7 tons in weight, Edmontosaurus was amongst the largest hadrosaurids, and like other hadrosaurids, it was a bulky animal with long, laterally flattened tail, a head with an expanded duck-like beak, strong, heavily built hind limbs, and long, slender forelegs. Additionally, E. regalis sported a small but solid crest towards the back of the skull. In life, Edmontosaurus would have inhabited the wetlands, plains, and coastal areas of North America, where it traveled in herds, browsing upon conifers, shrubs, ferns, horsetails, and other vegetation. As always, take care of my guys, gals, non-binary pals. Happy Fossil Day!